Welcome back to our PLC Servo Motor Position Control series. In Part 3, we demonstrated how to enhance system safety by integrating dual emergency stop functions into a servo position control system with overtravel protection. In this episode, Part 4, we take it a step further. We will explore how to run this PLC servo control system with the servo enable signal S-on kept on all the time. First, let us quickly review the key components required for this system. You will need a PLC, a servo drive, and a servo motor, a 3-button control station, and an S-on enable button plus an E-stop button. Also, 3 relays for our overtravel protection setup. These are the same components we used in Part 3, all available from ATO. You can find detailed product information via the links in the video description. This system is developed based on PLC pulse output control. The PLC outputs pulses to the servo drive and the drive rotates the motor. The control buttons and emergency stop button manage the drive enable, motor start, stop, and emergency stop. The key difference today is that we'll leave the enable signal S-on continuously on during the entire test through proper servo drive configuration without any external enable command. Let us walk through the physical wiring setup. The 3-button pendant station connects to PLC inputs. The emergency stop button is connected to the PLC input and wired in series with the S-on enable button. The S-on signal is also connected to pin 7 of the servo drive's CN3 connector. The PLC outputs pulses to the servo drive, which then drives the motor. Next, let us look at the wiring diagram in more detail. The diagram highlights the connections for the start and stop buttons, the enable button, and the emergency stop button. Next, the diagram shows the PLC input and output terminal configurations. CN3 wiring uses color-coded wires connected to specific terminals. Each wire matches a specific function and a pin number. Follow this table carefully when preparing your CN3 cable. This diagram shows the servo drive connections. For power, connect mains to L1 and L2. Control power to L1C and L2C. The motor connects via U, V, W, and ground. The encoder feedback connects through CN4. The 3 relays handle overtravel and alarm reset. See Part 2 for detailed relay wiring. Now configure the servo drive. Press M set twice to locate PN000, which defines the control mode of the drive. Press data to edit. Set the value to N0010. This enables position control using pulse train references. Press M set to save. Next, we configure the input signal allocation. Navigate to parameter PN50A. Set it to N2101. This enables user configurable input signal allocation, allowing us to customize which inputs are active. Within this mode, set the servo on input to N2171. This keeps the servo continuously enabled. Finally, press M set to save all changes. The drive is now configured. Now let's program our master controller. Create a new project. Select device type CP1E and set the CPU type to N40. In the ladder logic, the E-stop is a normally closed contact, so the PLC sees this input as constantly on. When you press the clockwise button, the PLC outputs a 20 kHz pulse train and the motor rotates clockwise. Pressing the counterclockwise button rotates the motor counterclockwise at the same frequency. Pressing stop halts pulse output, and the motor stops. If the emergency stop is pressed, the motor stops immediately, and all motion commands are interrupted. Let's re-verify our limit protection logic. KA1 stops motion if the clockwise limit is reached. KA2 stops motion if the counterclockwise limit is reached. KA3 acts as the alarm reset relay. If a fault occurs on the drive, it allows you to safely reset the alarm codes from the panel as detailed in the manual. Let's run a live benchmark test to see how it works. Power on the system. Notice that the servo system enters the on state immediately without any additional enable command. Press CW, motor rotates clockwise. Press stop, motor stops. Press CCW, motor rotates counterclockwise. Press E-stop, motor stops immediately. The servo motor only stops when pulse input stops. Without pulse input, the motor stops, but the drive remains enabled, so always ensure the E-stop is functional and PLC logic cuts pulses correctly. Ready to build or optimize your own motion system? Every single component featured in this series, from the 3-button pendant station and the emergency stop button to the PLC, servo motor, servo drive, and interposing relays, are available at ATO.com. But ATO offers much more. We provide a full spectrum of industrial automation solutions. Whatever your automation project, ATO has the quality products, expert technical support, and reliable tools to bring your ideas to life. Head over to ATO.com and chat live with our engineering support specialists to get expert selection advice for your next project. If you found this video helpful, please give it a like and share it with others. Subscribe to our channel for more tutorials on automation and control systems. Have questions or topic suggestions? Leave a comment. Need a quote or product details? Our team is ready to help. Thank you for watching. See you in the next video.